Good morning. In this class, we are going to do some problem in queuing model 2. Okay. So queuing theory model 2. Queuing theory model. In this model, there will be a multiple server. And infinite arrival. First in, first out. Infinite arrival, first in, first out. Okay. So here is this is a model 2. Here rho is equal to traffic intensity. Rho is lambda by S mu. In first model, rho is equal to lambda by mu only because S is equal to 1, because single server. Here the server is 2, so therefore here is S is greater than 1, therefore multiple server. So and also S mu is greater than lambda. S mu is greater than lambda. This condition must be satisfied in model 2. Okay. The next is LS. LS is equal to length of the system. The number of customers in the queue plus the number of customers in the service. So therefore that is nothing but system. So LS is equal to rho divided by 1 minus rho the whole square into S rho the whole power S divided by S factorial. S rho the whole power S divided by S factorial into P naught plus S rho. This is length of the system. Then length of the queue is equal to length of the system minus lambda by mu and Ws is equal to Ls by lambda. Ws is equal to Ls by lambda and Wq is equal to Lq by lambda. These four formulas are called little formula. Okay, so they are little formulas. Therefore, so then P naught is equal to the probability that no customers in the queue. P naught is equal to the probability that no customers in the queue. So the P naught is equal to 1 divided by sigma n is equal to 0 to s minus 1 into s rho the whole power n divided by n factorial plus s rho the whole power s divided by s factorial into 1 minus rho. So this is nothing but P naught. So similarly Pn is equal to S rho whole power n divided by n factorial into P naught if n is less than s. And again Pn is equal to S rho the whole power s divided by s factorial into rho power n minus s into P naught if n is greater than s. And the one more formula is probability of W is greater than 0. This is nothing but the probability that a customer has to wait. The probability that a customer has to wait is equal to S rho the whole power s divided by s factorial. S rho the whole power s divided by s factorial into P naught into 1 minus rho into P naught. That is S rho into 1 minus rho into P naught. This is also important. So therefore this four little formula plus P naught plus Pn plus Pw is greater than 0, S rho the whole power s divided by s factorial into 1 minus rho into P naught. So this is nothing but probability that a customer has to wait. The probability that a customer has to wait. Otherwise, we can say that a probability that the arrival would have to wait for service. Okay. So therefore, these formulas are most important. Okay. Now we are going to see one example. Okay. We are going to see one example. A supermarket. A supermarket has two servers. A supermarket has two servers. The customer arrives. The customer arrives in a Poisson fashion. At the rate of 10 per hour. 10 per hour. The service time for each customer is expected with mean of 4 minutes. Mean of 4 minutes. Okay. So the supermarket has two servers, therefore multiple server. The arrival is Poisson, therefore infinite arrival. Therefore this problem comes under model 2. Therefore problem comes under model 2. Okay. Then the question is find number 1 probability that a customer has to wait for service. Number 2 average queue length. Okay. Number 3 is average time spent by a customer in the queue. So these 3 questions asked. Okay. Solution. First of all, we go to decide this problem comes under which model. So already I said this is multiple server, Poisson arrival. So therefore this model is model 2, that is M bar S, infinite arrival, first in first out. Lambda is also given, rate of arrival is given directly. So I can take lambda is equal to 10 per hour. Okay. Then each customer, the service time of each customer is 4 minutes. The service time of each customer is 4 minutes. In 1 hour, how many customers will be served? So 1 customer 4 minutes, 10 customer 40 minutes, 15 customers 60 minutes. So therefore mu is equal to 15 customer per hour will be served. Okay. So therefore lambda is equal to 10, mu is equal to 15 and S is equal to 2. So mainly we have to decide first this problem comes under which model, then what is the rate of arrival, then what is the rate of service. Rate of service in the sense in 1 hour how many customers will be served. And S is equal to the number of servers. Okay. So using this thing we are going to find out solve one by one. Okay. The first question is the probability that a customer has to wait. First question is the probability that a customer has to wait. That is probability of W is greater than 0. So now we have lambda is equal to 10, mu is equal to 15, rho is equal to lambda by S mu. So S is equal to server is equal to 2, 10 by 30, therefore 1 by 3. S rho is equal to 2 by 3. S rho is equal to 2 by 3. So the first question is the probability of W is greater than 0. So therefore probability of W is greater than 0 is equal to S rho the whole power S divided by S factorial into 1 minus rho into P naught where P naught is equal to 1 divided by summation of n is equal to 0 to s minus 1 s rho the whole power n divided by n factorial plus s rho the whole power s divided by s factorial into 1 minus rho. So this is nothing but P naught. First of all, we can find what is P naught. So here s is 2, therefore n varies from 0 to 1. If n is equal to 0, n is equal to 1, we will take it. So therefore n is equal to 0, the first term will be 1 because power 0, in fact 0 factorial is also 1. So then n is equal to 1, what will happen? S rho is equal to 2 by 3. Upon 2 by 3, the whole power 1 divided by 1 factorial. Plus S rho is equal to 2 by 3 whole square divided by 2 factorial into 1 minus rho. 1 minus 1 by 3, this is equal to 2 by 3. 1 minus 1 by 3 is equal to 2 by 3. So therefore this is equal to 1 divided by 1 plus 2 by 3 plus this 2 by 3, this 2 by 3 will be cancelled. Therefore again we will be getting 2 by 6. Therefore again 1 by 3. Therefore 1 plus 1, therefore 1 by 2. So therefore P naught is equal to 1 by 2. Therefore P naught is equal to 1 by 2. So we have to calculate by using the formula. P naught by using the formula. Okay. Now we can find P naught, probability that W is greater than 0 is equal to S rho is equal to 2 by 3 whole square divided by 2 factorial into again 2 by 3 into P naught is equal to 1 by 2. So therefore again 2 by 3 and 2 by 3 will be cancelled. So therefore 2 divided by 3 into 1 by 4. So therefore this is equal to 1 by 6. 1 by 6, which is equal to, the probability is nothing but 10, therefore 0.1. 0 approximately, so this is 0.1. So probability of W is greater than 0 is equal to 0.1. Okay. So the second question is, find the average Q length. Find the average Q length. Average Q length is equal to LQ. LQ is equal to LS minus lambda by mu. So we need LS. Our LS is equal to rho divided by 1 minus rho the whole square. 1 minus rho the whole square into S rho the whole power S divided by S rho the whole power S divided by S factorial into P naught plus S rho plus S rho. So therefore this is equal to, what is rho? Rho is equal to 1 by 3 divided by 1 minus 1 by 3 is 2 by 3, 2 by 3 the whole square. S rho is equal to 2 by 3, S is equal to 2, again 2 by 2 factorial into P naught is equal to 1 by 2 plus S rho is again 2 by 3, S rho is again 2 by 3, clear? So therefore this is equal to, okay, so this 2 by 3 whole square, this 2 by 3 whole square will be cancelled, and 1 by 3 into 1 by 4 plus 2 by 3, therefore this is equal to 1 by 12 plus 2 by 3, 1 by 12 plus 2 by 3, so this is equal to, you take LCM 12, so therefore this is 1 plus 8, so therefore 9 by 12, therefore 3 by 4, so therefore length of the system is nothing but the number of customers in the system is 3 by 4, therefore 3 by 4 customers, therefore 3 by, so this is LS, 3 by 4 customers, LS. But what they are asking, LQ is equal to, so therefore LS minus lambda by mu, so this is equal to, LS is equal to 3 by 4, lambda minus mu, lambda is 10, mu is equal to 15, therefore 2 by 3, again take LCM 12, so therefore 9 minus 8, so therefore this is equal to 1 by 12, 1 by 12 is nothing but 0.533, so therefore, so the length of the Q is equal to customers, 0.533 customers, length of the Q. Okay, so this is question number 2. And question number 3 is, average time spent by a customer in the queue. So therefore, so question number 3 is nothing but WQ is nothing but LQ divided by lambda. What is LQ? LQ is equal to, so this is nothing but 1 by 12 is not 0.5, so this is equal to 0.0533, and because 10, so again 1 point, again we put 0 here, again point, again 0, 100, so therefore this is nothing but 0. So 5 into 96, the remaining 40, 3 12s are 36, okay, 0.0533. So therefore LQ is nothing but 0.0533 divided by lambda is equal to 10, so therefore this is equal to 0.00533 hours. 533 hours. We can convert this into minute. We will multiply it by 60. So you will be getting whatever you want. We will be getting. So therefore, waiting time in the queue is nothing but 0.0533 hours. Okay. Thank you.